Welcome to your second project. This project will deal with creating your own launch files. As you saw in the previous lecture, launch files help so that with one command, we can automatically run all nodes we are interested in and configure them with parameter values. In the previous project, a few lectures back, we created two nodes. One which publishes the RPM of our robot, and another which publishes the calculated speed of our robot based on that RPM value and our robot's wheel radius. So now I want you to create a launch file so that with one command, you can configure your parameter, such as the RPM value for the RPM publisher node, and a wheel radius parameter for our speed calculator node when launching them. Then I want to be able to see the speed topic being published to the screen, so I also want you to configure the launch file so it runs a ROS2 topic echo terminal command to print the values coming in from the speed topic. So let's break down what this project structure will look like. In this project, you will create a launch file, which as you learned from the last lecture is written in Python, so that when we run this launch file in terminal, it will start up our RPM publisher and speed calculator nodes, which we've worked on from the first project and have been using in the last few lectures. Now, I also want you to set up the launch file so that you can set the wheel radius parameter of our speed calculator node when we run this launch file. Now, if you remember, our speed calculator node has a publisher which publishes to the speed topic. So I want you to also configure the launch file to run the ROS2 topic echo command to print out the speed values that are currently being published by our speed calculator node. As always, remember when attempting this project to make sure you recompile your workspace when you make changes such as adding new launch files, and ensure your terminal is sourced to your workspace. Okay, with that, pause the video and give yourself about 10 minutes to give this project a go. How'd it go? I hope you are able to enjoy using just one terminal to launch the entire project rather than having 3 terminal tabs open running different commands. Let me show you one of the ways which you could have done it. Alright, with VS Code open, the first thing I'm going to do is create a new launch file. I will call mine launchproject.launch.py. To make this go by a bit faster, I'm going to copy the contents from my previous launch file in the previous lecture. Since we need to launch the RPM node, we can leave this node section as is, but I will go ahead and copy it, put a comma after the end of the node parentheses, and add a second node to the launch description list. This node will be our speed calc node, so we can keep the package name the same, but I'll change the executable and the node name like so. Great, with that I'm almost done. So now all I have to do is set the wheel radius parameter of our robot. The nice thing about launch files being in Python is that you can do operations like basic arithmetic in them. Note that you cannot set a parameter value in the launch file unless you have declared the parameter in your code. So I'll go ahead and do that in a bit. Then the last thing I'm going to do is modify the execution process to echo the speed topic. Alright, this is all I need to launch the entire project with one command. So I can go ahead and save the file. Now I need to make sure I have the wheel radius parameter declared in my speed calc node and that it uses the value to help calculate the speed of the robot. So I'll go ahead and open that file up. So the first thing I need to do is declare the variable. So I'll do this at the top of my class constructor, and I can just use the default wheel radius value to initialize it. And I'll go ahead and change the constant name to default wheel radius just so that we know that this will be changing. Now keep in mind this value will get overwritten by the value I set in the launch file, but it's still a good precedent for if you were to run the node by itself to make sure that you have a default value for your parameters if you're planning on using it. Then I will change my callback function so that it uses this parameter value. So I will create a float variable, which I load the value from our getParameter method of our node, and then I can use this value for our speed calculation. And then I will change our equation to use the value from this wheel radius parameter. That should do it. So I'll go ahead and save this file and recompile the project. Note that anytime you create new launch files, you will have to rebuild the project. But if you modify existing files, then there is no need to rebuild the project. So here I get a warning saying that there's a chance that our wheel radius parameter may be uninitialized. So if I wanted to get rid of that error, I could simply set this equal to the default wheel radius. That way I can rebuild this without running into that issue. Alright, so this time we don't get any warnings. So basically I create this wheel radius param variable, I initialize it with that default wheel radius constant we have at the top of our file, but then I just overwrite it when we call our get parameter function. You could have organized this in a different way. This is the way I'm going to go about doing it for now in this project. So go ahead and open up a terminal and change into our workspace directory, source it, and then I will run ros2 launch udemy ros2 package launch project.launch.py. So here we can see printed to the screen that our 2 nodes have indeed been launched, and we see the calculated speed being printed to the terminal. We can double check that everything is running as it should by opening a new terminal tab and running ros2 node list. And here we can see our 2 nodes are indeed running. Now let's double check that our parameter for our speed node was properly set, so I can run the ros2 param list command. And here we can see under speed calc node the wheel radius parameter. Then we can run ros2 param get for our speed calc node, and we will get that wheel radius parameter value. And we can see it is 0.1, which is what we set it to in our launch file, because 10 divided by 100 is 0.1. Last but not least, we can change the wheel radius parameter value to see our speed value change. And we see the data above change because we've changed the wheel radius parameter, so our speed calculations have changed. All right, I'll go ahead and stop this. All right, congratulations on completing another ros2 project. You have successfully created a launch file that launches multiple nodes, initializes parameter values, and can execute various commands, all within a single terminal command.